So, any question from previous discussions? We have talked about vector spaces, and we learned that span of vectors, column vectors or row vectors, that is also a vector space. For a matrix, we have rows and columns. Space spanned by the row vectors is called row space. Space spanned by the column vectors is called column space. Now we talk about null space. If you have a matrix A and a vector X, if you multiply this and get a zero vector, the solution to this equation, system of equations, you can find different vectors which satisfy this equation, and the space spanned by those vectors is called null space. Let's elaborate this point with the help of some example. Here you have a matrix A given by A. Can you find the solution to this system of equation? How would you find it? You will construct an augmented matrix and then perform elementary row operations to reduce it into echelon form, and then by back substitution you can find the solution to this system of equation. So performing elementary row operations on this matrix A, B, B is the right hand side of this system of equation, which in this case is equal to 0, and then you perform elementary row operations on this system of equations. You know now how to perform those operations. So by elementary row operations, this system of equation, augmented matrix, is transformed into this form. You had constructed an augmented matrix, then performed elementary row operations to get this augmented matrix equivalent. Then how to find the solution? By back substitution. So what do we get by back substitution? From this second row, x2 plus 2x3 plus 3x4, that is equal to 0, which implies that x2 is equal to minus 2x3 minus 3x4. And from the first row we have x1 plus 2x2 plus 3x3 plus 4x4, that is equal to 0, and x2 is given by this expression. So x1 plus what do we get over here? Minus 4x3 and minus 6x4 plus 3x3 plus 4x4, that is equal to 0, which implies that x1, 4x3 and 3x3 minus x3, 6x4, so minus 2x4, that is equal to 0, which implies that x1 is equal to x3 plus 2x4. So the system has infinitely many solutions. So among these solutions, we shall find solutions which are linearly independent. So let's take, here you can take any value of x3 and x4, that will give you a value for x1. Similarly, any value of x3 and x4 will give you a value of x2. So the simplest choice, for example, we can take x3 equal to 0, then what will be the solution vector? If x3 is equal to 0, what will be x1? And let's take x4 equal to 1. So then x1 will be equal to 2, and x2 is equal to minus 3. x3 we have taken it to be 0, and x4 we have taken it to be equal to 1. And now let's take the second situation, that is x3 equal to 1 and x4 equal to 0, that will give you this solution vector. For x3 equal to 1, so x1 comes out to be equal to 1, x2 is equal to minus 2, x3 is equal to 1 and 0. So there are infinite solutions to this system of equations. We have found two solutions which are linearly independent column vectors. Any linear combination of these two vectors will also be a solution to this system of equations. So the space spanned by these vectors, that is called null space, right? So what is null space? If you have for a matrix A and you have this system of equations, you find the solution vector x to this system of equation. The space spanned by these vectors, that is called the null space. You will find a maximum number of linearly independent vectors. Among this set, you will find the maximum number of linearly independent. The easiest approach for that case is first take, let's say, x3 equal to 0 and x4 equal to 1, and in the second case take x3 equal to 1 and x4 equal to 0. That is the easiest approach. And any linear combination of these two vectors will also be a solution to that system of equations. Yes? So these are column vectors. Here, what is dimension of this matrix? N by n in general. And then for this to be computable for multiplication, what should be its dimension? N by 1. So this is a column vector, right? Space spanned by these two column vectors, that is the null space for this matrix. Why is it not mandatory for this dimension? Yes. So this is a vector, this because this right hand side, this is a vector. So if right hand side is a vector, the left hand side must be a vector. So that is why the dimension of this is n by 1. So how will you find any other solution? So if, for example, here There is no restriction on x3 and x4. x3 and x4 are any real numbers. So if you, for example, take this choice, that is also quite valid. For example, I take x3 equal to 1 and x4 equal to 1. That is also a valid choice. However, the resultant vector that we shall get, x, that will be linearly dependent upon these two vectors. So that will be linearly dependent upon these two vectors. How that we can verify? Any linear combination of these two vectors will also be a solution to this system of equations. How we can verify it? Can you verify it? This statement. The statement that any linear combination of these two vectors will also be a solution to this system of equations. How you can verify it? For example, their linear combination, we have y, and let's call this thing to be equal to vector x1, right? This is vector x1 different from this x1. This x1 is a scalar x1. So just to differentiate this vector from this vector, let's call them x1, or if you are getting confused with this notation, then just we call it x and y. We have two solution vectors and their linear combination z is equal to c1x plus c2y. We want to verify that their linear combination is also a solution to this system of equations. Solution means this z must satisfy this system of equations. So a multiplied by z, what is that? A multiplied by c1 x plus c2 multiplied by y, which is equal to c1 a x plus c2 a y. What is a multiplied by x? 0, because this x is a solution. It satisfies this equation. What is a multiplied by y? 0, because y is a solution to this system of equation. So a multiplied by y is equal to 0. Their sum is equal to 0. It means that z is also a solution to this system of equation. So if x is a solution to this system of equation, y is a solution to this system of equation, then any linear combination of these two vectors will also be solution to this system of equations, and the space spanned by these vectors, solution vectors, is called null space. So the question is how we can ensure that there are at the most two linearly independent solution vectors. So in general, here what we can do is that what is x? What is x? X, it has four components: x1, x2, x3 and x4. It has four components. Among these four components, two can be independently chosen. Rest of the two are dependent upon other two, right? So it means that only two components of this vector can be chosen. So therefore, there will be only two vectors that can be independently generated. For example, here we had this case, we had this situation. x1 comes out to be equal to x3 plus 2x4, and x2 comes out to be 2x3 minus 3x4, and x3 and x4. We have only freedom on x3 and x4. These can be chosen and these will be determined by this choice. So you can choose them in different ways. This choice will generate linearly independent vectors. That is obvious by observation. Here is 0, here is 1. So these two vectors are linearly independent. That is by observation. And how many maximum linearly independent vectors? That is obvious from this thing. We have only these two variables which can be independently chosen. These are determined by these two. Yes, there is another question. That will be basically linearly dependent upon these two. Why? So, for example, let's write it in another way. That will be more intuitive. Can I write this vector in this way? So this solution vector x can be written in this way. x3, here this x is a vector, this x3 is a scalar. x3 multiplied by 1, minus 2, 1 and 0, plus x4 multiplied by 2, minus 3, 0 and 1. So x is a vector which is obtained by linear combination of these two vectors. So these two vectors are linearly independent. So this is another way to look at the same solution vector. So how many maximum possible independent vectors can be there? If I select this, the easiest way is select this one 0, this 1, and the other choice is the opposite. Is there any other choice? So you cannot generate more than two vectors which are linearly independent from these two vectors. दो vectors से अगर आपने maximum कितने linearly independent vectors generate कर सकते हैं? दो से ज़्यादा नहीं कर सकते हैं. So the question is, this is very valid question, and question is, does this solution, this null space, is it the same as R2? What is, just first ask me another question. What is the dimension of the null space? So we are किन लोगों का observation 0 की है? Dimension, what is dimension of its vector space? Maximum number of linearly independent vectors in that space, right? So how many vectors, linearly independent vectors, are in this space? Space V is this space x such that a multiplied by x is equal to 0. This is the set. How many maximum number of linearly independent vectors are there in this space? 2. So what is dimension of this null space? Dimension of null space for this matrix is equal to 2, and that dimension is also called nullity of a matrix. Dimensions of null space is nullity. Just I write it over here. Dimension of null space of a matrix is also called nullity of that matrix. And can you find a basis for the null space of this matrix? So a basis again is not unique for that matrix, this matrix. So nullity of this matrix A, which is the dimensions of null space of that matrix, that is equal to 2. And remember that this nullity is always related with rank of matrix in this way. I shall answer the question which was raised over here, but first we write it in this way. This rank of A plus nullity of A, that is always equal to number of columns in that matrix. Number of columns in that matrix. That is quite intuitive. So now there was a question. The question is this null space of this matrix A, is it the same as R2? Is it the same as R2? Just first, yes. What is R2? What was R2? How did we define it? The dimension of this null space is also 2. The only difference, is these are two quite different spaces. This R2 was this space. The vector had only 2 components, right? Here, how many components these vectors have? 4. The dimensions of this R2 is 2. The dimension of null space for this matrix is also 2, but these are 2 different spaces, right? Basis for these spaces is different. Dimensions is the same. Both the spaces have the same dimension. What is that dimension? Dimension is 2, but the 2 spaces are different. That was to address the question raised over here. Yes, any other question? Yes. Number of columns. That is number of columns. No, not necessarily. A has not to be necessarily a square matrix. A can be any matrix, rectangular matrix as well. So let's take a counter example. The observation is that, can we also write over here the columns of A? So just we give a counter example, that here we cannot write the number of rows of A. Which example should I take? Simplest example, let's say 1, 0, 0, 0. We have this matrix. So where is, let's find a solution to it. A multiplied by x. What should be the dimensions of x in this case? Size of x. What should be size of x? For matrices to be compatible for multiplication, this must be satisfied. So to find the solution, what was the procedure? Augmented matrix. So we can write another equation that is a trivial equation, but that will just help us to construct the augmented matrix. This last equation was not there. I have just written it over here. If that is confusing, even we can just omit it and solve it in another way. We want to solve this equation. A multiplied by x is equal to 0. So what is that? x1 equal to 0 and x2 equal to 0. And what is x3? x3 is any arbitrary. x3 is any arbitrary. So can you find any, what is a linearly independent solution? x1 is 0, x2 is 0. What is x3? Arbitrary. Let's take it to be equal to 1. So what is dimension of the null space of this matrix? Dimension of the null space of this matrix is equal to 1. And what is rank of this matrix A? 2. So is this satisfied? Rank plus nullity is equal to number of columns. So the other one, if I write rows over here, that will not be satisfied. So here is columns. किसकी dimension? Null space की dimensions. So you find the maximum number of linearly independent vectors. So this is solution. This is solution to this system of equation. What is x3? x3 any real number. So this is the solution to this system of equation. How many solutions are there? Infinite solutions. Among these solutions, how many linearly independent solutions are there? So I have just enlisted one solution. Can you tell me any other solution which is linearly independent from this one? There are infinite solutions. For example, this is also a solution. 0, 0, minus 3. That is also a solution, but that is linearly dependent upon this one. So this is the only one. There is only one linearly independent vector in this space. So dimension of the null space, which is the dimension of the space spanned by solution vectors, that is equal to 1. So nullity, that is also another name for dimensions of the null space. थोड़ा सा ऊंचा बोले कि आप बेसिस का पूछ रहे हैं कि व्हाट इज बेसिस? So the question is for a space. Just let's not relate it with this question. For a space, how many bases can be found? So what is the answer to this question? So basis is not unique. You can find different bases for a single space. However, the number of vectors in a basis, that is always fixed. So for example, for the null space of this matrix, what is a basis? This set, this is a basis, and this basis is not unique. In other, this is also a basis. Basis is not unique. However, number of vectors in that basis, that is always unique. Clear? Yes? If you have a vector space and you take a subset of that vector space, and if that subset is also a vector space, then that subset is called a subspace. Let me write it. A non-empty subset of V that also forms a vector space with respect to the same two algebraic equations, addition and scalar multiplication, that will be called a subspace. Let's clarify it with the help of examples. What is R2? What is R2? R2 is set of all these vectors x such that x is a real number, x which is composed of two components x1 and x2 such that x1, x2 are real numbers. Is it a space, vector space? Yes, because it satisfies the properties of vector space. What is dimension of that vector space? 2. What is the basis for that vector space? So you can find the basis. For example, one vector, there will be two vectors in that basis. One vector is, for example, 1, 0, and the second vector is 0, 1. So this is a vector space. There is any vector in this two-dimensional space where x1 and x2 are real. So any vector in this space that is a member of this set. Let's talk about this subset x, which is equal to x1, x2, such that x1 minus x2 is equal to 0, where x1 and x2 are real numbers. Is it a vector space? Can you find the basis for this vector space and dimension of this vector space? This is a line. So any vector which lies on this line will be a set of this, will be a member of this set. So you can verify that all those axioms are satisfied for this set. So therefore, this is a vector space. This set is a subset of this set. Therefore, this will be a subspace. Subspace, right? So the space of vectors on this line, the set of vectors on this line that are member of this set, that also form a space, vector space. All those axioms are satisfied, and this subset is called a subspace, right? Clear? So what is a basis for this subspace? Basis is 1, 1 for example, and basis you know is not unique. What is dimension of this vector space? 1. What is dimension of this vector space? 2. So dimension should not be confused with the number of elements in that vector. So dimension of a vector space is the maximum number of linearly independent vectors in that space. So dimension of this vector space is 1. A basis is given by this set. Dimension of this vector space is 2. What is the basis? Can you tell me a basis? 1, 0 and 0, 1. This is a basis, not unique. You can also, of course, find another basis for the same space. So what about this vector space? Space spanned by Span of vectors is always a vector space. We have learned it. So span of these two vectors is a vector space. What is dimension of that vector space? 2. And what is a basis for that vector space? So this set is also a basis, not unique. So my question is this vector space, what is this, is this the same as this one? No, these are two different spaces, right? This space, because this has two components, although dimension, what is dimension of this vector space? 2. The dimension of this vector space is also 2. However, these are two different spaces. This is a subspace of R3. This vector space is a subspace of R3. So these were some concepts related to vector spaces, and I wanted to solve some exercise problems, but okay, you can do that. Almost all the concepts are clear. No. R2 is not a subspace of R3. The question is whether R2 is a subspace of R3. So answer is no. It is not a subspace of R3. These are two different spaces. However, what was this space? This space, अगर यहाँ पे तीसरा कंपोनेंट में यहाँ पे वर्टिकल ले लूँ, थर्ड कंपोनेंट, तो ये वेक्टर कौन सी स्पेस को स्पैन कर रहे हैं? ये प्लेन को स्पैन कर रहे हैं, ये प्लेन को, ठीक है? So this space, which is a plane, is a subset of R3, subspace of R3. This space is completely different space. This is not a subspace of R3. Similarly, R1 is not subspace of R2. These are two different spaces.